Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 2551. Put marbles in bags. This problem is marked as hard, but it will be easy to understand. Just stay with me. And it is based on the concepts of array and greedy approach. Also, this question has been asked in companies like Amazon, TikTok, Apple, Flipkart, Uber. Let's have a look on the problem statement. They say that we have k bags, and apart from that, we are also given a zero index integer array weights, where weight I is the weight of the ith marble. You are also given integer k. These are the things given to us, and we have to do this operation, divide the marbles into k bags according to the following rule. No bag is empty, okay? And if the ith marble and the jth marble are in the bag, then all the marbles with the index between I to j indices should also be in that bag. It means we have to like a sub array from an array. If the bag consists of all the marbles with index I to j inclusively, then the cost of the bag is weight I and weight j. They are just trying to make the problem statement a bit confusing. They are just talking about the sub-arrays. The score of distributing the marbles is the sum of the cost of all the k bags. Okay. Firstly, let's try to understand the problem statement. See, firstly, the weights are given to us, and they are asking us to divide these weights into k bags. Let's say this is the bag 1 and this is the bag 2. And we have to divide in such a way, let's say I pick two indices, I and j. I have to pick that subarray and put it in that bag inclusively, I to j. Then the remaining ones are this one, I to j, new I or new j, 5 and 1. So 5 and 1 are placed in this bag. If there were one couple of more elements, then they will also be in this part. So these two bags we have created using this weights. And now what is the cost of the first bag? First element value plus last marble value. 1 plus 3, that is the cost, similar to all the other bags. And once we divide all of these marbles in some k bags, then after all of these distributions, we might have multiple possibilities for this distribution. In the end, return the difference between the maximum and the minimum scores, among the marble distributions. It is not always distributing 2 bags, it can be 4 bags. In those 4 bags, 2 are the maximums, 2 are the minimums. So we just have to return the difference between those values. Okay, now let me understand. Let me show you what is given to you. Okay, now let's come to an example. Here, the weights array is given to us. Along with that, an integer k is also given. We have to divide these marbles into k bags. Let's say in this section I have divided the marbles into k bags. Firstly, let's say the first marble is in the first bag and all the other marbles are in the second bag. The distribution will look like this. And from this distribution, what is the cost of this distribution? Score after distributing all the marbles is the sum of all the cost. Okay, every bag will give us a cost. So let's say the first bag is going to give me the cost, which is ith marble, jth marble. In this case, I and j are same. Ith marble is having one weight and the jth marble is having 1 weight. So this is the cost for first bag. And what is the cost for second bag? Cost for second bag is first marble, I marble, j marble, 3 plus 1. So what is the score? So score is this, sum of cost of all the bags. 1 plus 1, 2 plus 4, that is 6. Right? And see, if it is k equal to 2, it means only 2 bags we are having. If it is 2 bags, it's something like a slice over the array, cutting into 2 pieces. Okay, so what can be the other kind of distribution, other possibility of distribution? Let's say we are taking first 2 elements in the first bag and the remaining 2 elements in the second bag. In that case, the cost of the first bag will be first element plus second element, that is 1 plus 3. This is the cost of the first bag. Cost of the second bag is 5 plus 1. Now the overall cost is 5 plus 1 6 and 4, with that is 10. And in this possibility, first 3 elements are in the first bag. For the first bag 1 plus 5, and the second bag 1 plus 1, 6 and 2, that is 8. So these are the scores from different possibilities, and from these scores what I have to return is return the maximum and the minimum score among the marble distributions. So what is the maximum score? Maximum score is 10 here, and the minimum score is 6 here. Then difference between the maximum score and the minimum score is 10 minus 6, that is 4. It means that if we divide these marbles with weights given to us in k bags, then there might be multiple possibilities, and from those multiple possibilities, these are the scores I'm getting. Sometimes one time I'm getting 6 score, 10 score, 8 score. Among those scores, whatever is the maximum score and whatever is the minimum score, I just have to capture the difference. Return the difference between the maximum and the minimum scores among the marble distribution. So yeah, in this case 4 will be the value, and we have to return 4 from this. Now the score is 4, but if we try to analyze the score further, 10 is equal to 1 plus 3 plus 5 plus 1. 1 plus 3 plus 5 plus 1. This is value of 10. Minus, what is the value of 6? 1 plus 1, 3 plus 1. If I try to analyze this, so these are the possibilities, and among those possibilities, if I try to have a look on the first element, first marble and the second marble, those first marble and the second marble, first marble and the last marble will always be considered. Okay, see, as the score of the bag is from I to J, and I will definitely be there, J will definitely be there. So for the first partition, first bag, first marble will always be the part of that bag, and for the last bag, the last marble will always be the part of that bag. It means that this value 1 1 1 will always be there, and this value 1 1 1 last marble score will also be there. And as ultimately we have to capture the difference. If we have to capture the difference, so this one will be there, this one will be there, and what is the remaining value? Remaining value is 3 plus 5. Just a minute. 3 plus 5 is there, and what is the remaining value for the minimum score? 1 plus 3. If you just try to have a look, my marble bag like weights was on 1 3 5 1 1 3 5 1. So this is the score I received from this partition. In this partition, this one and starting and ending will always be there. So if the starting ending will be there in all the partitions, so there is no need to check that, because one is there on the left side, one is there on the right side, it will cancel out. The last one will also be cancelled out. What are the remaining ones? 3 plus 5 on the left side, 1 plus 3 on the left side. And this left side partition, like possibility, came from this partition. When I just made a cut at this point, because I wanted to have 2 bags, right? So these values came into picture. So these 3 and 5. So 3 plus 5, we can directly consider it. The value can be 3 and 5. If I just capture it, I can use it while calculating the score. In this case, and this possibility came from the partition like this 1 3 5 1. So it came from this. If this is the partition, then starting one and ending one is skipped, And what I have to use it? This portion, 1 plus 3, which is 4, right? So this is something I want you to understand. This example is very important. But in this case, the value of k is 2. It means we are dividing these weights into 2 portions. And when we dividing into 2 portions, the first value, because the cost of every bag is I to j, whatever the item in between, we are not going to care about those. So the cost will always be the first element and the last element on that portion. In short, we are making a cut to this array, to this array, and whatever is the remaining sub arrays, capture the first and the last element. It means that the very first element and the very last element will always be the part of that score, right? And ultimately we want to find the delta of the scores, maximum score minus minimum score. So if the first and the last element is available in all the possibilities, so it means that it will also be part of maximum score and minimum score. So that will cancel out. So there is no need to consider that. So whenever we are making a cut, so this value will come into picture. Now let me just have a look on the weights again. 1, 3, 5, 1. And the value of k was 2. It means we are having 2 bags. 2 bags means 1 cut is sufficient. If I just make that 1 cut here, the score I require is 1 plus 3. If I made the cut here at this moment, the score I require is 3 plus 5. Because this 1 and 1 is common. First one and the last one is common in all the possibilities. So just ignore it. And the third cost is 5 plus 1. These are the cost actually. 5 plus 1. Okay. So for the first possibility, black possibility, the score was 1 plus 1 and 3 plus 1, right? So ultimately 1 plus 1, 1 and 1. This is something common. First one and the last one, this is common among all the possibilities. So just ignore it. And the remaining one was 1, 1, 1, 3, 1. So 1 plus 3, which is 4 is the cost of this possibility. And when I make a cut between 3 and 5, then this is the cost. Because first one and the last one is common. See, just making a blue color. This plus this will be the cost for the second part, left part, and this plus this will be the cost for the right part. So in this case, first one and the last one is common. I'm ignoring it for all the possibilities. 3 plus 5. 3 plus 5 is something I'm going to capture. So whenever I'm making a cut, the items adjacent to that cut is being used. So in the third possibility, 5 plus 1 will be used. That is 6. So here, if I just maintain an array and I capture all of these values, so if this is 4 in size, I will be having 3 pairs in total. And for the first pair, 1 and 3, the value is 4. For the second pair, 5 and 3, the value is 8. The third pair, the value is 6. See, these are the pairs. And among these pairs, if the value is 2, just pick the maximum one and the minimum one, right? You will get the answer. 8 plus 4 is equal to 2. You will get the answer. And how we are going to use the maximum and minimum one? If it is 2, I would have definitely checked by doing one iteration. But what will happen if the value of k is equal to 3? In the previous example, when I was having k equal to 2, I was making only one cut. If I just making one cut, the maximum value will be something like this. First value and the pair value, this value and the last value. And for the minimum, it will be the same. First one and the pair value, that was 1 plus 3 in that case, because the cut was like this. So in this case, what is the last value? That is 1. And here these value get cancelled out. This and this. and here there is only one pair. There's only one pair. Why? Because value of k is equal to 2. It means we have to pick only one pair. But let's say if the value of k is equal to 3, it means we are going to make 2 cuts, because bags are 3. If the bags are 3, the cuts should be 2. Let's say those 2 cuts are like this. If those 2 cuts are like this, so this will be in the first bag, second bag, third bag. For the first bag, what is the first value and the last value? That is 1 plus 1. For the second bag, what is the first value and the last value? 3 plus 3, because there is only one element. And for the third bag, the first value is 5, last value is 1. See, these last values are common. Last value, last value. What are the other things that I can capture is, this is something, one pair. Let me take it blue. This is one pair. That is 1 plus 3. This is the pair. And the second value is 3 plus 5. 3 plus 5. Right? So among those pairs that I have derived from the array, I am now considering two pairs. And to get 2 pairs, because see, these pairs are going to help us capture the cost minus the first value minus the last value, right? And score, what is the score? Score is sum of cost of every bag, and this will be like sum of pairs, whichever pairs are used. And if we are having 2 bags, only one pair is being used. And if we are having k is equal to 3 bags are there, so 2 pairs are being used, right? So let me show you the example. If 1 3 5 1 is there, 1 3 5 1, if this is there and the value of k is equal to 3, it means we are going to make the division into 3 bags. 3 bags means I can make 2 slices, 2 cuts in this array. Let me make 2 cuts like this, 1 and 2. In this case, for the first section, the cost is 1 plus 1. For the second section, cost is 3 plus 5. For the third one, cost is 1 plus 1. And as we already know that the first element, last element is common among all the cost, among all the possibilities, so that will cancel out automatically. Apart from that, what is the remaining one? So this 1, so this 1 and 3, this 1 and 3, this 5 and 1, 2 pairs are required. And these possibilities can be any number, whatever in number. So to get the maximum score, maximum difference of the score, firstly I should know the maximum score and minimum score. And score I can get to know from these pairs. My array was like this, 1 3 5 1. So for this 3 size pair array was 1 and 3, which is 4, 3 and 5, which is 8, 5 and 1, which is 6. In this case, if k is equal to 2, I was choosing only 1. If k is equal to 1, k is equal to 3, I will be choosing the top 2 for the maximum score and the least 2 for the minimum score. And let's say when my pair array is a bigger one, and having multiple elements, and k was 4, it means I am going to pick 3 maximum pairs and 3 minimum pairs. In this case, this shows that we definitely have to sort these pairs. So to sort these pairs, we are going to use n log n time to sort it. So firstly, the weights are given to us and we have to sort those weights and to get the maximum score and minimum score. Now let's try to work on our algorithm. First of all, weights are given to us, right? weights are given to us, and among those weights we have to divide those weights into k bags. In short, we can say that we have to make k minus 1 slices. K minus 1 cuts we have to make so that we can get k slices. So for that, what I realized that first of all I need to prepare pair array, and pair array will be something like this. Let's say this is something 1 5 3 1. So the pair array will be prepared something like this: I equal to 0 to I less than n minus 1, and pair of I is equal to weight of I plus weight of I plus 1. Now the pair array is prepared. And second part is we have to make k slices, and for that we are going to make k minus 1 cuts and k minus 1 top pair and the least pair we are going to use. So definitely we have to sort all of these pairs. Let's say in this case the pairs were 4 6 8 6 were the pairs. Now if I do the sorting, it will be something like this: 4 6 8. Now among these pairs I need to find the maximum difference. I need to capture the difference between the maximum pair and the minimum score. Return the difference between the maximum and the minimum score. To capture the maximum score, I need to k minus 1 top pairs. To capture the minimum score, I want k minus 1 bottom pairs. So k minus 1 from the starting, k minus 1 from the ending, and just plus the maximum values minus the minimum values, and you will get the answer. You have to sort it and pick the k values. Yeah, that's all we have to do. And what is the time and space complexity? First of all, we are having a weight. We have prepared the pair array in order of n time, linear time. Sorting took order of around n log n time, and then order of k time. So ultimately the time complexity will be order of n log n time, and the space complexity is order of n time because I am capturing the pair difference. Now let's do the coding so that you will get more understanding on how I'm writing the code. Firstly, let's capture the length of the weights dot length, and here I need to prepare an array that is called pairs. New integer for n weights, we have n minus 1 pairs, and let's fill those pairs: I less than n minus 1, I plus plus. Pairs of I is equal to weights of I plus weights of I plus 1. There will be 1 plus 1, I plus 1, because I'm going till I less than n minus 1. Okay, now the pairs are prepared, and I have to sort it. Arrays dot sort. So the code is very simple. You just have to understand the example, actually how I build the approach using this example. So arrays dot sort pairs, and now it is in the increasing order, and I have to pick k minus 1 pairs from starting and ending. And to pick k minus 1 pairs, I less than 0, I less than k minus 1, I plus plus. And let's say my answer, I'm going to add something. Add the bigger part is at the right side, correct, and the smaller part is at the left side. Left side is definitely I because I'm starting from I, and you can just directly return the answer. This answer is long format. They're expecting long value, and for that int long answer, let's initialize it with 0. This is the answer, and from 0 to I minus 1, I am picking the minimum value from the starting of the pairs array and the larger value from the ending of the pair. What is the last index? So the last index in the pair is n minus 1 minus 1, right? See, because this one. And for I equal to 0, I need to pick the last element. and for I equal to pick 1, I need to pick second last element. For I equal to 2, third last element, like this. So here I'm picking the k-1 element from the starting. Now this answer will ultimately give me the score of the maximum score and the minimum score, because maximum score is made up using maximum pairs and the minimum score is made up using k-1 minimum pairs. So this is something you should understand, otherwise this problem is very easy. Let's run our sample test cases. Sample test cases are passed. I'm submitting the problem. It got submitted successfully and we have completed the March month as well. And in case you get any doubt, you just comment down below and I will be happy to help. Thank you guys. Bye bye.